Hello, and thanks for mathing with me today. In this video, we're going to identify intercepts and use them to graph lines. A linear equation can be written in the form ax plus by equals c, where a, b, and c are real numbers, and a and b are both not zero. This is called standard form. The graph of a linear function is a line, and non-vertical lines are functions called linear functions. Not all linear graphs are linear functions because not all lines are functions. So if we look at these examples on the left, we see that anywhere we were to draw a vertical line, this line passes the vertical line test, which means it is a function. Similarly, this line also passes the vertical line test. However, this line does not, right? Every point on that line is going to break that rule. All right, so this is not a function, however, it is still linear. Okay, it is a linear graph. The x-intercept is the x-coordinate of the point where the graph touches the x-axis. So this is the x-axis. Our x-coordinate is right here. So this value of a is the x-intercept. And then here we have our horizontal line. This line does not touch the x-axis anywhere, so there is no x-intercept. And in this graph of a line here, we have a vertical line, and this here is the x-intercept, the point where the graph crosses the x-axis. The y-intercept then is the y-coordinate of the point where the graph touches the y-axis. This is where x equals 0, so anywhere where on the y-axis the value of x is 0, and this here is the the y-intercept where x equals 0, and this here is the y-intercept where x equals 0. A vertical line, however, does not touch the y-axis unless it is the line x equals 0, so therefore there is no x-intercept for most of those types of lines. Let's find the x and y intercepts in the examples below. We're going to find the points that are the x and y intercepts and write them as ordered pairs. So in this first example, we see where the x-axis is right here. The point where the graph crosses the x-axis is the point 2, 0. So the point 2, 0 is the x-intercept. Similarly, when we look for the y-intercept, this is the y-axis. The point where the graph crosses the y-axis is the point 0, -1. So 0, -1 is the y-intercept. Now, in number 2, we have an equation. So here we have to calculate to find the x-intercept and y-intercept. So what do we notice about the graphs in the previous example? Remember, the x-intercept is where the graph crosses the x-axis. What is the y value here? The y value is 0, right? The y value of the x-intercept is always 0. So if we know that, we can plug in 0 for y to find the x-intercept. So we have 5x minus 2 times 0 equals 10. 2 times 0 is just 0, so we get 5x equals 10, so x equals 2. So the x-intercept is the point 2, 0. Similarly, we know that when we look at this graph, and any graph, right, if the graph, the point where the graph intercepts the y-axis, the x value is always 0. So we can plug in 0 for x in our equation, so we get 5 times 0 minus 2y equals 10. 5 times 0 is 0, so negative 2y equals 10. So y equals -5. So the point 0, -5 is the y-intercept for the equation 5x minus 2y equals 10. Pause the video and try examples number 3 and 4. Find the x and y intercepts and write them as ordered pairs. Hopefully you paused the video, and in number 3 you found the x-intercept is -2, 0 because that's where the graph crosses the x-axis, and the y-intercept is 0, the point 0, 3 because that's where the graph crosses the y-intercept. In number 4, we have an x-intercept of negative 10, 0. When we plug in 0 for y, we get x equals negative 10. And for the y-intercept, we get 0, 6, because we plug in 0 for x, we get y equals 6. The reason why we found the intercept is because this is one way to graph. When a function or an equation is given in standard form, intercepts is a good strategy to use to graph the function. So how we graph when they are in standard form, we find the x and y intercepts like we did in the previous problems, and then we plot those ordered pairs, and just we know that when we have 2 points, we can connect them to draw our line. So we will just connect those 2 intercepts and draw arrows at the ends. So in these examples, we're going to find the intercepts and use the intercepts to graph. So let's find the x-intercept. Remember, when we find the x-intercept, we're just plugging in 0 for y and then solving for x. So we get 3x equals 12, so x equals 4. So our intercept is the point 4, 0. That's our x-intercept. So we can go ahead and plot that on the coordinate plane. Next, we want to find the y-intercept. We do that by plugging in 0 for x, and then finding our y value. So we get negative 4y equals 12, so y equals negative 3. That means the point 0, negative 3, is our y-intercept, and we can plot that on the graph. Now that we have 2 points plotted on the graph, we connect with a straight line, and we draw arrows at the ends of our graph. In a future video, we're going to learn that it is not best to graph using intercepts when we have an equation in this form, but just know that you can always graph using intercepts. It really doesn't matter, but the best way to graph is by slope-intercept, identifying the intercept and using the slope. But we're going to go ahead and graph using intercepts just to show you that you can do it with any form. So again, we're going to find our x-intercept first by plugging in 0 for y. And then we get negative 4 equals negative x, so 4 equals x. So the point 4, 0 is going to be our first intercept. Then we want to find the y-intercept. That's where x equals 0, so y equals negative 0 is just 0 plus 4, right? So y equals 4. So our point is 0, 4. Then we just want to connect our points with a straight line and draw arrows at the ends. Now we can graph using intercepts. Pause the video and try graphing the equations in numbers 7 and 8 on your own. Hopefully you paused the video and you found the x and y intercepts for both numbers 7 and 8 and you were able to graph. Make sure your graphs look like mine. In this last type of graphing example, we are going to graph horizontal and vertical lines. Something that helps me remember when I'm graphing these types of lines, because often they are mixed up, is remembering that if I'm graphing the line y equals negative 2, for example, I think to myself, y is always negative 2. So you have to remember what your y values are. And if I want to graph y equals negative 2, this would be the graph. So every point on this line has a y value of negative 2. So for every value of x, there's a y value of negative 2. Similarly, in number 10, we have x equals 2, which means that everywhere on the graph, every point on this line, x equals 2. So this is the vertical line, x equals 2. Pause the video and try graphing number 11 and number 12 on your own. Hopefully you found that the y-axis is the line x equals 0. So your graph should be right on the y-axis for the line x equals 0. And for the line y equals 3, y is always 3. You're going to have a graph right there. I hope this video was helpful for you in learning intercepts. Thanks so much for mathing with me today.